So this is the sinusoidal functions unit that I'm going to be covering today. We're going to start with the basics, just looking at a sinusoidal function on a graph. We're going to determine the max, minimum, range, period, equation of axis, and the amplitude. This is just to get all the terms down so we know what we're looking at when we see a graph like this. So the max is going to be the max height that this graph reaches. That is this point here. It's going to be 5. The minimum height is going to be the lowest point that it reaches and also where it starts, which is going to be 1. The range is y is every real number such that y is less or greater than 1. Is greater or equal to 1, but is less or equal to 5. And that is because that's our max height here, so it's not going to pass 5 and it's not going to pass 1. Okay, and then the period is just how long it takes for the graph to reach the starting point back to 1, like full rotation back to the starting point. So 1 period here, and we're talking time, is going to be 12 seconds, because it takes 12 seconds to reach back to 1. And the equation of axis is going to be the middle point here. The equation of axis is y equals 3 in this case. And then the amplitude is the distance from the equation of axis to the maximum or to the minimum. In this case, it goes up by 2 and then goes down by 2 here. So the amplitude is going to be the absolute value of 2. Moving on, this question is asking to graph this equation and state the transformations. So here I have y equals sine 4 times 3x plus 1. Knowing this, I see sine of 4. The 4 is our a value, which is going to be our amplitude. That's going to be the distance from the equation of axis, which is going to be y equals 1, to the maximum height. And the 3x there means that we're going to have a vertical stretch by a factor of 4. Sorry, by a factor of 3. So that means from the starting point here, it's going to stretch by a factor of 3. That's going to be our new point here, and here it's going to vertical stretch from the y-axis, from the y line to 3. So it's going to be there. So our new graph is going to look like this. And that's how our function looks. Now for this equation here, I'm going to graph this equation. This is y equals 3 cosine of 2x plus 60 degrees plus 4. To graph this, there's multiple steps I'm going to take here so that I can get this onto the graph. So to break it down first, when I have the k value here, I'm going to factor it out to take the 2 out. So my new equation is going to be y equals 3 cosine times 2 times x plus 30 degrees and then plus 4. So first off, I want to find the scale. The scale is going to be how much my x-axis is increasing by each time. That's going to help me find out these numbers here. So the scale is going to be the GCF of 360, as that's an entire cycle, divided into 4 groups, times the k value. And the k value is 2, so I have 4 times 2. And it's also going to be d, the GCF of d. So then the GCF here is going to equal 45 degrees and of 60 degrees. And the GCF of 45 and 60 degrees is going to be 15 degrees. So this is our scale and how much it's increasing by each time. Next, we have the period. The period is how long it takes for the function to finish one whole cycle. So the period is going to be 360 degrees divided by k, the absolute value of k, and that is going to give us 180 degrees. So that means one full cycle is going to be 180 degrees. So the equation of axis is going to be the c value here, because we know that it translates 4 units up, as it says plus 4. So the equation of axis is going to be y equals 4. And then lastly, the amplitude is just how much it's increasing or decreasing by from the equation of axis. And the amplitude is going to be the a value here, which is going to be the absolute value of 3. So now that I have all of these factors here, I can dictate that my starting point, first of all, we know that this is a cosine, so it's going to start at the maximum height. That's going to be here. And it's going by 15 degrees each time. So we're going to start at 15 degrees, which is here, comma 7. So that's there. And now when I graph this, it's just going to go through by 15 degrees each time to the equation of axis, then to the minimum, and then back to the equation, and then back to the maximum. So it's going to look something like this. And then it continues on. And that's how this graph is going to look. Moving on, this question is asking, it says, a sinusoidal function has a max height of 8 meters at 20 seconds and a minimum height of 2 meters at 80 seconds. Determine the equation. So I've written down here the max height is 20, 8. We know that. I've plotted it here on our graph because we know that's the maximum. And the minimum height is going to be 80, 2, which is down here, which is the minimum height. So this is the one cycle, or sorry, half. This is going to be half a cycle because I have the top and the bottom of the equation. So now that I know that starts at the max, I know it's going to be a cosine. So this is my basic equation here. It's y equals a times cosine of k times x minus d, and then plus c. So when I'm figuring out all of these other factors here, I'm first going to look at my equation of axis. The formula for the equation of axis is going to be the maximum plus the minimum divided by 2, because I'm trying to find the middle line here. So it's going to be 8 plus 2 divided by 2, which is going to be 5. So that's going to be this line here I've drawn out. So the equation of axis is y equals 5. And then now for the amplitude is just going to be the distance from the equation of axis to the maximum or the minimum, which means it's going up by 3. So the amplitude is going to be 3. Okay, so now for the period, I know that if this length here equals half a period, then 1/2 of a period is going to be 80 seconds. 80 seconds. That means one period is going to be half times 2 is going to be double the amount, which is 160 seconds. So now that I know the length of one period, I can find out my k value. So the k value formula is going to be 360 divided by the period, which is 160. That means the k value is going to be 2.25. Now that I have all the numbers that I need here, I can rewrite my equation. So y is going to equal the amplitude, which is 3, times cosine of the k value, which is 2.25. There's no d value here, so it's going to be 225x, and then plus y equals 5. Because it's going up by 5. So this is going to be our new equation for this graph. So when I'm graphing this is just a half period, but now it starts here since it's cosine. It's going to go down and hit the y equals 5 here. It's going to go back around and hit the minimum value here, and then of course it would go back up and repeat, and it would reach this period again, 8, at 160 seconds, which would be far along on the end of the graph. Okay, so lastly, we're doing word problems with sinusoidal functions. This one here is using a pendulum model. So the question is, the following equation represents the height in centimeters of a pendulum, and t seconds that the model moves. The equation here is y equals 10 sine 3 times t minus 30 plus 12. Determine the maximum and minimum height, the height of the pendulum after 30 seconds, and the period. So here I've written out the equation again. I've determined the A, the K, the D, and the C value. So seeing this here, I'm going to start with my amplitude. I know the amplitude is the A value, so my amplitude is going to be the absolute value of 10. Next, if I want to find the period, how much one cycle is going to be, I'm going to do 360 divided by the K value, which is going to be 3, and that's going to give me 120 seconds. So that means I know one full cycle is going to end at 120 seconds, which is here. Next, now that I have my amplitude, I'm looking at my C value here, which is 12. That's going to be the equation of the axis. That means y equals 12 is going to be right along here. And if the amplitude is 10, that means it's going to be increasing from the y value by 10 and then decreasing to get the max and the minimum. So from 12 plus 10 is going to give me 22. This is going to be my maximum here. And then from 12 minus 10 is going to give me the minimum, which is 2. Now that I have this, first of all, I see the D value here is -30. This is a transformation. That means I'm going to shift 30 degrees to the right. So from my original point here at 2, since this is a sine, I know I'm going to start at the y here. So I'm shifting 30 degrees to the right, and that is my starting point here. And then, of course, the max and the minimum we know. And if we're looking at the scale, if we're shifting 30 degrees to the right, it's going to go 30 degrees after every point. That's going to go back to, 120 seconds. I'm going to draw my function going up through the equation of the axis to the maximum, and then back down here. That's going to be one full cycle, one period. And then, of course, I can just rewrite it there, and that's what the equation looks like on a graph. Next, this question is asking if the movement of the pendulum was decreased by 40%, what is the new equation? So if I'm looking at the movement of the pendulum going like this, if I decrease it by 40%, that's going to be a vertical compression. A vertical stretch. It's going to go down. So basically, I'm just going to reduce the amplitude by 40%. So the amplitude is 10. So I'm going to do 10 times 0.6 because 6 is what's left of 40%. That's going to give me 6. So my new amplitude here is going to be 6. That means from my equation of axis, it's only going to go up by 6, which is here, 6. And then when it goes back down, it's going to decrease and be at 6. For 6, it's going to go here. So now I can redraw my function going through all of the same points. This one's going to end up here. And of course, it's going to hit the equation of axis every time. It's just stretching here, like that. And then lastly, when we're looking at this all together, I can rewrite the new equation with the new amplitude. So my new equation is going to be y equals 6 sine 3 times t minus 30, and then plus 12. And that is our new equation.